Okay, guys, this is 822. How can I picture it? So sometimes seeing is believing. So the ability to visualize a concept makes it easier to remember and understand. So you may be interested to know that you can visually represent tangent, cotangent, secant, cosecant, even the Pythagorean identities as well. So the diagram below, which also is a resource page, so make sure you get that. Let's complete the parts below to represent all the trig functions using the unit circle. So I'll try to draw this. I actually have it PDF'd over here, but I'll do my best to give you guys what this looks like. So we have circle. Well, I thought that would work. Obviously it didn't, right? So we have a circle, right, which we then quad, right? And then we have P to B, B to D, right? This is a unit circle, so our radius is 1. We have B to C. Right, and then we have some value A up here. Okay. So, use triangle PDB to complete the parts below. What is the sine of theta? Okay, sine of theta. Remember, sine is opposite over hypotenuse. So the opposite is BD over the hypotenuse, which is 1. So we're talking about this line, right? So this is our sine, right? It's BD, or that Y value. Okay? What is cosine? Well, cosine is adjacent over hypotenuse. The adjacent is PD over the hypotenuse, which is 1. So again, we're talking about this side. Don't know what I just did. But that side is our cosine, right? It's PD, or the X value. Okay? Explain why angle A is theta. Okay, so if we're looking at this, okay, and we're looking at understanding triangles, okay, we should know that this angle is 90 degrees. So therefore, angle A and angle C, right, so A plus C have to equal 90 degrees. Okay, agreed? All right, well, let's take angle C, for example. We know this is 90 degrees, which means so is this. So angle PBC, right, C, so we know P plus C is 90 degrees, right? We know P is theta, so theta plus C is 90. So now if we look at this, the big triangle, PAC, right? We know that A has to be theta. Okay? So therefore, PDB and ABP are congruent triangles. Okay? So using ABP and the fact that the sine of A is equal to the sine of theta, what is the sine of A? Okay, well, the sine of A, again, is opposite over hypotenuse. So opposite is 1. Hypotenuse is PA. Okay, what is the cosecant of A? Well, we learned yesterday that the cosecant is just 1 over the sine. So this is really PA. So this is cosecant of theta, this side right here. So we now have sine, cosine, and cosecant. Okay, what's the tangent of A? Okay, so the tangent is opposite over adjacent. Well, the opposite is 1. Adjacent is AB. So AB, right? So cotangent, this is cotangent. Why? Because it's 1 over that. So AB is the cotangent. That means BC is the tangent. Okay, now it says use PBC to answer the questions below. What is the tangent of theta? Right? Tangent of theta, sine over cosine. That's where we get that, right? It's opposite. Tangent of theta is opposite over adjacent, right? Which is sine over cosine. Okay. What is the cosine? We've already done that. Cosine of theta is BD. Right? Well, what is the secant of theta? Right? Actually, I'm using the wrong triangle, guys. I apologize. Okay, tangent of theta on the big one, right? So we're talking about opposite over adjacent. So opposite is BC over adjacent, which is 1. So we know the tangent's that BC line. Cosine is adjacent over opposite. So cosine is 1 over PC. Sorry, adjacent over hypotenuse. Yes, that's right. Sorry, 1 over PC. Okay, so the secant is PC. So this whole line is the secant. So we have secant, cosecant, and then tangent, cotangent. Okay, so let's fill these in. Let's look at these, and let's see if we can fill these in. So sine of theta is BD. Cosine of theta is PD. Tangent of theta is BC. Cosecant of theta is AP or PA, either one. Secant of theta is PC. And cotangent of theta is AB. Okay, next thing, the Pythagorean identities can be displayed using the graphic in the previous problem. Apply the Pythagorean identity to each of the following triangles and write the corresponding identity. So triangle PDB. So triangle PDB, we're right here, right? Pythagorean triangle, right? So it's a squared sine squared plus cosine squared plus cosine squared equals 1 squared. Okay, let's look at the next one. Triangle PBC. So now we're looking at PBC, this one. Okay, so that would be tangent squared plus 1 squared equals secant squared. Tangent squared plus 1 squared equals secant squared. Okay, and then the last one, triangle ABP. We're talking about this one. So this is 1 squared plus cotangent squared. 1 squared plus cotangent squared equals cosecant squared. And then use the graphic in the problem 89 to show that this big Pythagorean theorem, right? So we're talking about the big one now. So we're talking about the whole triangle. Okay? So if you look at the whole triangle, right, the big part there is cotangent plus tangent squared, and then the bottom is secant squared, the side is cosecant squared. So that works too. Right? And then the last thing here, 72, says it's all in the name. Right? Where did the 6 trig come from, and why does sine go with cosecant, cosine go with secant? Right? So sine comes from the Latin sinus, which means curve. In the Arabic, sine means bowstring or the chord of an arc. In the diagram on your research page, reflect PDB vertically and describe that, right? So here's what they're talking about, right? So you have this triangle. If you reflect it vertically, you have this triangle, which makes this look like a bow and arrow, right? That's where it came from. Okay, cosine comes from the complement of sine. Which angle in the diagram is the complement of theta? Right? It's this angle, right? Tangent comes from the Latin word to touch. In many mathematics, the tangent line is a line that touches the curve at only one point. Okay? So how is that shown, right? So if you look at the tangent, right, it just touches it right here, touches the circle, 1 point. Okay? Secant means to cut. In mathematics, a secant line intersects a curve on 2 points. So if you look, secant line cuts through the circle. Okay? And then cosecant and cotangent are the complements of secant and tangent. So really cool of like understanding where this came from, how it all makes sense. Yeah, this is 822.